Welcome to the training series on Textile Color Lab Operations and Technical Manual. In Chapter 1, we will discuss the introduction to Textile Color Labs. In this chapter, you will learn what a color lab is, why it plays a critical role, and how it supports the complete dyeing and finishing process in a textile mill. 1.1 Purpose and Scope of a Color Lab. Now let us understand the purpose and scope of a color lab. A color lab, also known as a dyeing lab, plays a critical role in the entire dyeing process of a textile mill. It is the heart of color development and approval, where customer expectations are transformed into practical and achievable production results. The main purpose of the color lab is to develop and approve new colors, or lab dips, as requested by buyers and merchandisers. At the same time, the lab ensures that dye recipes are cost-effective, technically suitable, and easily reproducible on the production floor. The color lab also supports bulk dyeing by providing accurate and reliable dye formulations that can be followed consistently during production. When a color lab is well managed, it significantly reduces dyeing problems, minimizes rework, and helps avoid delivery delays. Ultimately, it ensures right first time dyeing, leading to improved quality, efficiency, and customer satisfaction in bulk production. 1.2 Role of the lab in supporting dyeing and finishing. The color lab does much more than simply matching shades. It plays an active role in ensuring overall product performance and production stability. Before bulk dyeing starts, the lab verifies critical color fastness requirements, such as washing, rubbing, and light fastness, to ensure the shade will meet buyer standards. The lab also supports production by troubleshooting when bulk shades go off-tone. By analyzing the root cause, the lab helps correct issues quickly and prevents further losses. In addition, the lab works closely with the finishing department to understand how different finishing processes, such as enzyme, silicone, or resin finishes, can affect the final shade appearance. For example, if a buyer requests a reactive turquoise shade on cotton, the lab not only develops the correct color, but also checks its stability after washing. This ensures that when the shade goes into bulk production, the dyeing floor does not face rejections, rework, or customer complaints. Key functions and responsibilities of a color lab manager. A color lab manager is responsible for leading the lab team to consistently deliver accurate and reliable results. One of the primary responsibilities is ensuring precise lab dip preparation and timely approvals. Equally important is submitting lab dips on time to buyers and merchandisers, as any delay can directly impact production schedules. The lab manager also oversees the development of dye recipes that are not only technically correct, but also cost-effective and reproducible in bulk production. In addition, they are responsible for the routine calibration, proper operation, and maintenance of lab instruments such as spectrophotometers and auto-dispensers to ensure accuracy and consistency. Another key responsibility is manpower planning and training. The lab manager must ensure that all lab technicians are well trained and strictly follow standard operating procedures. Close coordination with the production team is also essential to maintain shade continuity from lab approval to bulk dyeing. Finally, the lab manager must ensure proper documentation and record keeping, which is critical for internal controls as well as buyer and compliance audits. Typical daily tasks of a color lab manager. At the start of the day, the lab manager reviews all new lab dip requests, checks incoming submissions, and prioritizes urgent or buyer-critical shades. Next, they approve lab dips or recommend retrials, ensuring that each dip matches the approved standard and meets buyer expectations. The lab manager also checks spectrophotometer calibration logs to confirm that daily calibration has been completed correctly, which is essential for accurate color measurement. Throughout the day, they discuss any dyeing or fastness-related issues with the dye house manager or the QA team to get feedback from production. Another important task is guiding lab technicians, especially when working on critical or complex color matches, to ensure precision and consistency. Finally, the lab manager updates lab dip and bulk dyeing records regularly, maintaining proper traceability and supporting future analysis or troubleshooting when issues arise. Color lab's place in the total supply chain. The color lab acts as a critical link between marketing or buyers and the production floor. Its role is to ensure that the buyer's design vision is accurately translated into a practical and achievable production reality. At the same time, the lab confirms that the mill can reproduce the approved shade consistently in bulk, while staying within cost, quality, and time constraints. The impact of a strong and well-functioning color lab is significant. It leads to fewer rejections, faster deliveries, and greater buyer satisfaction. Ultimately, this directly improves the factory's efficiency, reputation, and overall profitability. Common problems when labs are weak. Many factories face serious challenges because their labs do not follow proper systems and controls. One common issue is lab dips that appear visually acceptable in the lab but fail during bulk dyeing, often due to poor process matching between lab and production. Another frequent problem is high shade variation, or high delta E, between lab samples and bulk production. Weak labs also tend to have slow lab dip turnaround times, which can delay production schedules and shipments. In addition, incorrect or unverified color fastness results often lead to buyer complaints and rejections. Finally, a lack of proper training means technicians may not fully understand how to use instruments correctly, resulting in inaccurate measurements and unreliable results. All of these issues highlight why a strong, well-managed color lab is essential for consistent quality and smooth production flow. To conclude Chapter 1, let's review the key takeaways. First, a color lab is not just a support function. It is a critical control point in the textile dyeing process. The performance of the lab directly impacts quality, efficiency, and customer satisfaction. Second, the color lab manager plays a central role in balancing quality, cost, and delivery by coordinating between buyers, the lab team, and production. Third, setting up clear procedures, providing proper training, and effectively using instruments such as spectrophotometers are essential to achieving reliable and repeatable results. Finally, a strong color lab operation ensures right first-time dyeing, reduces rework, minimizes delays, and leads to happier buyers and a more profitable operation. Quick tips for lab manager. First, always double-check new dye combinations for color fastness before giving approval. This small step can prevent major problems during bulk production. Second, make it a habit to maintain and review daily calibration logs. Buyers and auditors often look for these records, and they demonstrate strong control and professionalism in lab operations. Finally, maintain clear and open communication with the production team. This helps avoid the common, lab versus bulk, blame game and ensures everyone works together toward the same quality goal. Thank you for joining today's session. I hope this training has given you a clear understanding. If you found this session useful, please share your feedback so we can continue improving our training programs for you. Welcome everyone. In this chapter, we will focus on one of the most critical success factors in textile labs and dye houses: right first time, or RFT. Understanding RFT will help us reduce rework, save cost, and build strong buyer confidence. Let's begin. What is RFT and why it matters? RFT, or right first time, means completing a job correctly on the very first attempt, without any correction or reprocessing. In dyeing, this means the lab recipe works perfectly in bulk production, and the approved shade is achieved without repeated trials. RFT is extremely important because it reduces waste, saves time and energy, improves delivery performance, and strengthens buyer trust. Top-performing mills typically target 90% or higher RFT, meaning most dyeing lots pass on the first run. How lab accuracy drives bulk dyeing RFT. The lab is the foundation of RFT in bulk dyeing. If the lab recipe is incorrect, production failure is almost guaranteed. Issues like wrong dye strength, lab-only optimization, or ignoring finishing effects directly lead to shade variation or rejection in bulk. That is why standard lab practices, accurate shade matching, and proper testing are essential for achieving strong RFT performance. Measuring and tracking RFT performance. To improve RFT, we must first measure it. RFT percentage is calculated by dividing the number of lots dyed correctly on the first attempt by the total number of lots dyed. For example, if 360 out of 400 lots pass on the first try, the RFT is 90%. Tracking this number monthly helps identify problems early and control dyeing costs. Common causes of poor RFT from the lab side. Many RFT failures originate in the lab. Common causes include poor dye compatibility testing, lab machines that do not represent bulk conditions, and insufficient technician training. Uncalibrated instruments and poor documentation also lead to wrong shade decisions. These issues must be controlled at the lab level to prevent costly production rework. Best practices to ensure RFT from the lab. To ensure strong RFT, lab teams must follow disciplined best practices. Lab dyeing conditions should closely mimic bulk production parameters. All dyes should be checked for batch variation, and recipes must be validated with final finishes applied. Regular instrument calibration, clear documentation, and continuous staff training are key pillars of RFT success. Quick example, lab recipe check sheet. This simple lab recipe check sheet shows how RFT can be controlled before bulk production. By confirming liquor ratio, finish effect, delta values, fastness results, and data recording, the lab ensures the recipe is truly production ready. Such checklists significantly reduce shade failures and improve bulk success rates. Key notes from Chapter 2. To summarize this chapter, RFT is a major driver of profitability and delivery performance in dyeing operations. Lab accuracy directly determines bulk dyeing success. Regular tracking of RFT helps identify issues early, while standardized lab checks reduce rework and buyer complaints. A disciplined lab leads to consistent quality and satisfied customers. Lab Manager Cheat Sheet for RFT. This cheat sheet highlights the daily habits of high-performing labs. Always mimic bulk conditions, keep instruments calibrated, verify fastness before approval, and track lab-to-bulk performance. These simple practices create a strong RFT culture across lab and production. This concludes Chapter 2 on understanding RFT in the lab and production. By applying these principles consistently, we can reduce redyeing, save cost, and deliver quality right the first time. Thank you for your attention. Let's move to the next chapter.
Welcome to Chapter 3 of the Technician Training Series, Fundamentals of Dyes and Dyeing Chemistry. This chapter is part of the Textile Lab Training Program. In this chapter, we will cover 5 key areas: the types of dyes for each fiber, how dye bonds to fabric, selecting dyes based on end use and cost, common dyeing problems from wrong selection, and valuable lab manager tips, and a quick cheat sheet. Different fibers require specific dye classes. For example, cotton uses reactive, direct, or vat dyes. Polyester needs dispersed dyes. Nylon typically uses acid dyes. Knowing your fiber type is essential for choosing the correct dye class. Reactive dyes are widely used for cotton fabrics. They form strong covalent bonds with the cotton fiber, which results in good wash fastness. The process involves adding salt and alkali to create the covalent bond. A wrong pH can prevent the dye from fixing onto the fabric. Here is a quick look at other major dye classes. Direct dyes are simple and economical but have lower wash fastness. VAT dyes offer excellent fastness but require a reduction process. Dispersed dyes are for polyester and applied at high temperatures. Acid dyes are used for nylon and wool, bonding with amine groups and requiring a pH of 4 to 5. Dyes stick to fabric through various fixation mechanisms. Reactive dyes use a strong covalent bond. Direct dyes rely on weaker hydrogen and van der Waals bonds. Dispersed dyes sublimate into the fiber. The correct dyeing parameters like pH, temperature, and chemicals are critical for forming these bonds. The reactive dye process on cotton involves 5 steps. Load fabric, add salt to push dye onto the fiber, add alkali to form the covalent bond, maintain the correct pH, and achieve good fixation and exhaustion. Correct pH is vital for bright color and strong bonding. Selecting the right dye requires considering fiber type, fastness requirements, cost balance, and end use. Always match the dye class to the fiber, end use, and buyer standard to ensure quality. This decision table illustrates dye selection examples. For a 100% cotton t-shirt needing high wash fastness, reactive dye is suggested. For a CVC blend requiring good rub fastness, a reactive plus disperse combination works. The real decision balances fiber, buyer specifications, cost, and machine capability. Wrong dye selection leads to common problems. Using direct dyes on export knits results in failed wash tests. Low migration dispersed dyes on polyester can cause uneven dyeing or streaks. Using a weakly substantive reactive dye on heavy fabric often leads to patchy dyeing. Wrong dye selection equals failed bulk production and buyer complaints. Observe these visual examples. Incorrectly using direct dye on an export knit results in a failed wash test. Applying dispersed dye at the wrong temperature on polyester causes streaks. Correct practice, such as reactive dye on cotton or dispersed dye at 130 degrees Celsius, ensures bright, level shades and meets fastness standards. Train your team to recognize these differences. Before every dye selection, lab managers should check the buyer's technical specifications, verify machine parameters to ensure they meet dyeing requirements, and check dye compatibility, especially when mixing dispersed dye brands. Always confirm dye specifications with the supplier, as strength and fastness can vary by lot. This quick cheat sheet summarizes dye selection by fiber. Cotton needs reactive dye, alkali, and salt. Polyester needs dispersed dye and high-temperature dyeing. Nylon uses acid dye at a low pH. Wool uses acid or metal complex dye with a gentle temperature ramp. Print this sheet for quick lab reference. The key takeaways for Chapter 3 are: choose the dye class based on fiber type and end use. Understand the bonding mechanism for troubleshooting. Always confirm dye specs with suppliers, and keep reference cards for quick checks. The right dye plus the right process equals first-time right bulk production. This concludes Chapter 3. Up next is Chapter 4, working with dyes, balancing cost and quality. Remember these 3 fundamentals: know your fiber, know your chemistry, and know your buyer specifications. Thank you.
Welcome, everyone. In this session, on Chapter 3, Fundamentals of Dyes and Dyeing Chemistry, we will focus on balancing cost and quality, helping color lab managers develop cost-effective, buyer-approved dye recipes without compromising quality. Section 4.1 discusses why balancing cost and quality matters. Dyeing involves controlling cost while meeting quality standards like color fastness. Overusing expensive dyes reduces profit, while cheap dyes can lead to costly redyeing. A balanced recipe ensures efficiency and reproducibility. In this example, we see cost versus quality in action for navy on cotton. Using a smart combination of a high-strength reactive blue and a supportive, economical blue achieves similar fastness at a much lower cost. Section 4.2 covers factors that influence dye cost. These include dye strength, shade depth, the number of dyes in the combination, the yield of the dyes, and supplier pricing. Section 4.3 outlines the quality requirements to meet. Even when reducing cost, standards for shade accuracy, wash fastness, rubbing fastness, light fastness, and reproducibility must be maintained. Failing quality means redyeing, costing more than any initial savings. Step 1 is to start with buyer quality standards. Check the buyer tech pack for all fastness and testing requirements before selecting any dye. These requirements set the minimum performance level for your recipe. Step 2 is to select dyes by function. We use a main dye for the body shade, supportive dyes to fine-tune the hue, and potentially a cost optimizer dye to replace part of the main dye for lower cost without sacrificing quality. Step 3 involves running lab dip trials. Prepare 2 to 3 options for every shade. Premium, high-quality dyes. Balanced, mix of premium and cost-effective dyes. And economical, lower-cost dyes for internal study. Step 4 is to evaluate performance. Before approval, check the color accuracy using the Delta E reading. Review fastness test results and compare the cost per kilogram of fabric for all trial options. In this practical example of navy on cotton, we compare 3 options. The balanced recipe was approved, meeting the required fastness while reducing cost by about 21% compared to the premium option. Section 4.6 covers tools for cost-quality decision-making. These include a spectrophotometer for color accuracy, fastness test equipment, a dye costing calculator, and a dye database or shade library. Section 4.7 provides lab managers cost control tips. These include keeping historical dye records, working with suppliers on new economical dyes, avoiding overshading, standardizing recipes, and reusing approved combinations. Here is a quick lab cost-quality checklist. Review buyer fastness requirements, confirm dye strength, run an economical combination trial, check that Delta E is within tolerance, ensure the fastness test is passed, and calculate and document the recipe cost. Key takeaways from Chapter 4. Cost and quality must be balanced. Smart dye combinations reduce cost without compromising fastness. Documenting results builds internal knowledge, and supplier collaboration can reduce cost by 5 to 15% on key shades. This concludes Chapter 4 on working with dyes, balancing cost and quality. Mastering this balance between cost efficiency and buyer-approved quality ensures every recipe becomes a competitive advantage. Thank you for watching. Let's now move on to the next chapter. Welcome, everyone. In this session, we will focus on Chapter 5, Preparing and Managing Lab Dips. This guide offers color lab managers best practices and practical tips for handling requests and achieving approvals. Section 5.1 covers the lab dip request workflow. A lab dip is a small dyed fabric sample submitted for approval before bulk production. Requests typically come from a buyer's tech pack, a merchandiser, or a redye order. A request form requires minimum information, including the style or PO number, buyer name, fabric type, required shade with a color reference, approval method, fastness requirements, and the submission due date. Section 5.2 outlines the lab dip preparation procedure. The lab must replicate bulk dyeing conditions as closely as possible, which involves reviewing the request, selecting appropriate dyes, preparing the recipe, accurately weighing ingredients, and dyeing on a lab machine that matches the bulk process. Preparation continues with post-treatment, drying, and pressing. Then perform visual and instrumental shade matching using a spectrophotometer and D65 light. Conduct required fastness tests, and finally, submit the sample for internal review before buyer submission. Section 5.3 covers the lab dip approval process. Internal approval includes checking visual and instrumental readings, attaching fastness reports, and verifying the recipe's reproducibility. Submission to the buyer requires 2 to 3 pieces per shade with an approval tag and matching reports. Once approved, the recipe is marked for bulk use, sent to dyeing, and a reference swatch is archived. Section 5.4 focuses on recording and archiving lab dip data. A strong documentation system ensures traceability. Key records include the lab dip logbook, spectral report archive, fastness test summary, buyer comments/feedback, approved recipe file, and the LabDip swatch library. Here is a quick LabDip process checklist. Review requirements, select the correct dye class, prepare an accurate recipe, match machine parameters to bulk, achieve a delta E within target, conduct fastness tests, obtain internal approval, tag and record buyer submission, and archive the recipe and swatch. Key takeaways from Chapter 5 are: LabDip preparation must closely follow bulk conditions. Clear documentation ensures traceability. Approval involves not just shade, but also fastness and reproducibility. Good management builds buyer confidence and reduces disputes. Thank you for watching. Let's now move on to the next chapter. Welcome, everyone. In this session, we will focus on Chapter 6, Monitoring Lab Dip Matching and Shade Control. This chapter provides a guide for evaluating lab dips, controlling shade variations, and maintaining consistency between lab and bulk dyeing. Shade control is critical. Continuous monitoring ensures consistency from lab to bulk, reduces redyeing and variation, and builds buyer confidence. Without it, you risk bulk rejections and financial losses. Visual assessment is the first step in shade evaluation. Key techniques involve checking lighting, viewing angle, shade arrangement, and conducting metamerism checks. For visual assessment, use D65 daylight for most buyers. View the sample at a 45-degree angle under standard lightbox conditions, and always avoid natural sunlight or inconsistent lighting. For shade arrangement, place the standard in the center and samples on both sides. Compare 2 to 3 dips side by side. Perform a metamerism check under 2 different light sources, like D65 and TL84, to ensure no shade shift occurs. Instrumental assessment with a spectrophotometer ensures accuracy and consistency. Remember daily calibration, taking at least 2 readings, setting appropriate delta E tolerances, and saving the values for traceability. This example report shows how instrumental readings help. LabDip 1 passes with a delta E of 0.92, while LabDip 2 fails at 1.35 and requires a recipe adjustment. Shade bands are physical color references that minimize disputes. The process involves preparing 3 to 4 approved lab dips, getting buyer approval for the acceptable range, and ensuring production matches within this band. Troubleshooting common issues means addressing the root cause. For light shades, increase dye. For dark shades, reduce dye. Poor metamerism requires replacing dyes with compatible ones. For bulk production, send the approved shade card and recipe to the floor. Conduct a first lot review using the spectrophotometer, record delta E values, and only adjust the bulk recipe if necessary, documenting all changes. Best practices for lab managers include maintaining a master shade library, training staff, cross-checking metamerism for export buyers, using a daily shade control log, and weekly auditing spectrophotometer logs. Here is a quick shade control checklist to confirm all steps are complete: daily calibration, visual and instrumental matching, metamerism check, shade band prep, bulk verification, and data recording. This image shows a close-up of the spectrophotometer taking a reading, confirming the importance of instrumental assessment for accurate color matching. Key takeaways from Chapter 6 are: use both visual and instrumental assessment, maintain delta E tolerances and shade bands, monitor bulk production, and ensure proper documentation for audits and consistent results. Thank you for watching this video on monitoring lab dip matching and shade control. Master these practices to build buyer confidence, reduce rework, and deliver consistent quality from lab to bulk. Let's now move on to the next chapter.
Welcome, everyone. In this session, we will focus on Chapter 7, Developing Dye Recipes and Processes, This chapter offers a step-by-step guide for creating cost-effective, reproducible dye recipes that ensure RFT and buyer approval for new color lab managers. The purpose of recipe development is to create a blueprint for bulk dyeing. A well-developed recipe ensures accurate shade matching, reproducibility, cost efficiency, and compliance with buyer fastness standards. Failures in the lab recipe lead to shade variations, re-dyeing, and shipment delays. A dye recipe includes more than just dyes. It involves all chemicals and process parameters. Key components include the dyes themselves, auxiliary chemicals like salt and wetting agents, pH control, and dyeing process parameters like time and temperature. Steps 1 and 2 involve analyzing requirements and selecting dye classes. Review the buyer color standard and check fabric composition. Confirm fastness requirements and match the dye to the fiber type. Finally, consider dye compatibility when mixing shades. Step 3 is to prepare the initial recipe. Use dye strength data from the supplier's Certificate of Analysis, or COA. Start with a standard depth, like 1% for a medium shade, and split the color components into main hue, supporting hue, and brightness control. Step 4 is running lab dip trials. Prepare 2 to 3 trials with slight variations, such as a high-strength premium dye trial, a balanced combination, and an economical mix. This helps determine the best blend for quality and cost. Step 5 is to evaluate and adjust the recipe. Use a spectrophotometer to measure delta E and check fastness properties like wash, rub, and light resistance. Adjust dye percentages or add supportive dyes if needed to meet the target shade and standards. Step 6 is finalizing and documenting the recipe. Select the most cost-effective recipe that meets all standards. Record it in the lab database for future reference and approve it for bulk production. Autodispensers and spectrophotometers are valuable tools. Autodispensers reduce weighing errors and improve reproducibility. Spectrophotometers and their software suggest dye combinations and reduce trial and error. Remember to always verify software suggestions visually. Process control is essential for reproducibility. Uncontrolled processes can ruin even a perfect recipe. Focus on critical parameters such as pH control, temperature rise rate, salt addition, and maintaining the machine liquor ratio precisely. In this case study for Zara Burgundy, we see 3 trials. Trial A was too dull. Trial B was close. Trial C, a balanced tri-dye combination, achieved the target delta E of under 1.0 and was approved. Documentation and control mean maintaining a dye recipe sheet for every approved recipe. This record must include the recipe number, fabric details, dye percentages, performance data like delta E and fastness, and the approval date. Use this quick checklist. Confirm color and fabric data, select the correct dye class, create the initial recipe, run and evaluate lab dips, verify delta E and fastness are within tolerance, and document and archive the final recipe. Key takeaways from Chapter 7 include: a strong process reduces bulk re-dyeing, use a combination of selection and testing, always document recipes for traceability, and work closely with suppliers for data and cost optimization. Thank you for watching the video on Chapter 7, Developing Dye Recipes and Processes. Let's now move on to the next chapter. Welcome everyone. In this session, we will focus on Chapter 8, Working with Lab Equipment. This video serves as a guide for the Color Lab Manager on key machines, proper usage, and maintenance required to achieve consistent dyeing and accurate color matching. Why does equipment handling matter? Proper management ensures accurate shade development, reproducibility in bulk production, and consistent test results. It also reduces human error and improves efficiency while preventing failed trials and wasted resources. A color lab relies on several key pieces of equipment, including dyeing machines, autodispensers, spectrophotometers, light boxes, hot air ovens, fastness testers, and essential measurement tools like pH meters and scales. To operate the lab dyeing machine, follow these steps. Load the swatch and dye solution, set the temperature profile, maintain proper agitation and dosing, rinse and post-treat, then dry and press the sample before assessment. Follow these do's and don'ts for the lab dyeing machine. Ensure your machine type matches your bulk equipment, and always avoid overloading beakers or allowing chemical residue to build up. Autodispensers increase consistency and save time. They offer accurate volume control, reduce operator error, and improve repeatability. Remember to calibrate pumps weekly and verify output against system values. When using a spectrophotometer to compare lab dips to buyer standards, calibrate daily with white and black tiles. Select the correct illumination, take multiple readings, and save your results with the appropriate reference. For color matching, use these delta E benchmarks. A value of 1.0 or less is an excellent match, 1.1 to 1.5 is often acceptable depending on the buyer, and a value over 1.5 is likely to be rejected. Use a light box for visual matching. Use D65 for daylight, TL84 for store lighting, UV to check fluorescence, and F/A for warm light. Remember to clean regularly and replace lamps after 2,000 hours. Fastness testing is vital. Wash fastness testers simulate domestic or industrial washing, while rubbing testers check durability against friction. Always perform these tests before submitting samples to a buyer. A strict maintenance schedule is essential. Perform daily and weekly cleaning, calibration, and checks for all equipment. Crucially, keep an up-to-date maintenance logbook signed by a technician or the lab manager. Lab safety is paramount. Always wear protective gear, keep chemicals in clearly labeled containers, maintain eye wash stations, and ensure material safety data sheets are readily available for all substances. The key takeaways for this chapter: mastering your equipment is essential. Regular maintenance improves results, proper documentation aids audit readiness, and safety is never negotiable. Use this quick checklist to stay on track. Ensure your dyeing machine is ready. Verify calibration of dispensers and spectrophotometers, monitor lamp hours, clean your fastness testers, and update your logbooks. Thank you for watching this guide on working with lab equipment. Consistent handling and safety practices remain the foundation of reliable color results. Thank you for watching. Let's now move on to the next Chapter 9, Managing Lab Production and Workflow.
Welcome everyone! In this session, we will focus on Chapter 9, Managing Manpower and Lab Workflow. In this video, we will explore the essential strategies for managing lab production and workflow to build a smooth, efficient, and result-oriented color lab operation. Why does workflow management matter? Effective management ensures right first-time results, faster buyer approvals, accurate recipe transfers, and the efficient use of resources. Precision is key, as even minor delays can disrupt bulk production. A lab manager's key responsibilities include planning daily production, assigning tasks efficiently, maintaining lab equipment, approving recipes, communicating with stakeholders, and monitoring critical KPIs like delta E levels and turnaround times. Success relies on a structured daily schedule. This begins with morning reviews of pending dips, followed by dedicated hours for dyeing and shade matching, midday progress checks, afternoon final approvals, and end-of-day reporting for bulk follow-up. Optimize your scheduling by prioritizing critical buyer shipments and using digital trackers to stay organized. Assign tasks based on the specific skill levels of your technicians and track average turnaround time by shade family. Effective manpower management is vital. Clearly define roles. Managers oversee operations, senior technicians handle complex tasks and mentoring, technicians run trials, and helpers provide essential support. A skill matrix can help identify training needs. The daily lab dip control sheet is a fundamental tool. It tracks pending work, monitors real-time progress, and helps managers identify and resolve bottlenecks before they impact the bottom line. Boost production by grouping similar shades, standardizing processes with SOPs, minimizing idle time for equipment and staff, and leveraging digital tools to accelerate recipe development. When facing peak workloads, maintain efficiency by adjusting shift hours, strictly prioritizing tasks based on deadlines, assigning expert staff to complex shades, and monitoring right first-time results daily. Monitoring KPIs is essential for long-term success. Key metrics like right first-time percentage, average delta E, turnaround time, reprocessing rates, and equipment uptime provide a clear picture of lab performance. A lab manager must maintain proactive communication across the organization, including the dyeing floor, merchandising teams, buyers, and QC teams. Clear, immediate communication is crucial when addressing issues like metamerism. Maintain organized records, including production sheets, calibration logs, and approval registers. Utilizing digital platforms, such as shared online sheets or ERP systems, will improve transparency and overall operational efficiency. Commit to continuous improvement by conducting weekly reviews, applying the PDCA cycle for process corrections, providing ongoing technician training, and benchmarking your lab's performance against industry standards. Use a daily review checklist to ensure nothing is missed. This includes verifying auto dispenser and spectrophotometer readings, approving final recipes, logging KPIs, and updating all relevant buyer reports. To summarize, prioritize efficient workflow, ensure clear role distribution, monitor KPIs to drive improvements, and stay committed to training and SOP updates. Thank you for watching. Let's now move on to the next Chapter 10, Ensuring On-Time Dyeing Approvals. Welcome everyone! In this session, we will focus on Chapter 10 Ensuring On-Time Dyeing Approvals. This video provides a practical guide for textile color lab managers to consistently meet approval timelines. Why do on-time approvals matter? Delays directly impact production flow and delivery commitments. Key risks include production holdups, missed deadlines, unnecessary cost overruns, and reduced buyer confidence. Consider the real-world impact. If a buyer requires a 3-day approval cycle, and your lab submits DIPs after 5 days, the entire production schedule is delayed, risking late shipment penalties. Let's review a typical approval workflow. It begins with receiving a buyer request, followed by recipe preparation, lab DIP execution, color measurement, internal review, dispatch, and finally, follow-up. To maintain efficiency, aim for a 72-hour approval cycle for most shades. This includes 4 hours for recipe development, same-day execution of the first dip, and efficient measurement and submission processes. Managing priorities is essential. Assign your most experienced technicians to high-priority tasks, like urgent bulk shipments. Schedule medium-priority tasks into your regular workflow, and fit low-priority development samples into any idle capacity. Utilize effective tools to improve performance. Maintain an approval tracker in Excel or your ERP. Hold 10 to 15-minute daily status meetings to align the team, and use digital communication for faster updates and better traceability. Establish clear communication protocols. Internally, update production teams upon confirmation. Externally, proactively inform buyers of any potential delays with clear reasons, and revise timelines to maintain transparency. Quality assurance is vital to avoid repeated trials. Always ensure recipe accuracy. Verify shade tolerances. Calibrate your instruments regularly, and maintain consistent lab conditions, such as temperature and lighting. Common challenges include shade mismatches, recipe delays, or slow buyer feedback. Address these by recalibrating instruments, optimizing workloads, assigning dedicated staff to chase approvals, or further training your team. Monitor your KPIs to stay on track. Key metrics include turnaround time, the percentage of approvals completed on the first attempt, approval pending rates, and average delta E values. Maintaining a detailed approval tracking log is a simple yet effective practice. It helps you monitor the status of each brand's requests and provides clear remarks for future reference. Standardize your operations. A clear SOP for the approval workflow, from initial logging and task assignment to internal review and buyer follow-up, is essential for consistent results. Finally, commit to continuous improvement. Regularly review performance data. Train staff in advanced techniques. Implement lean methods to reduce waste, and benchmark your lab's efficiency against industry standards. In summary, timely approvals keep production on track and buyers satisfied. Use systems, track your KPIs, and practice proactive planning. Thank you for watching. Let's now move on to the next Chapter 11, Optimizing Lab Productivity and Throughput.
Welcome everyone. In this session, we will focus on Chapter 11, Optimizing Lab Productivity and Throughput. In this video, we will explore how to plan, monitor, and optimize textile color lab performance using proven techniques and tools. Why does productivity matter? A lab that consistently delivers accurate, quick, and cost-efficient results ensures higher right first-time percentages, faster buyer approvals, smoother transitions to bulk dyeing, and improved overall profitability. Tracking metrics is the first step toward improvement. Key performance indicators include samples per day, time to approval, right first-time percentages, machine utilization rates, redip rates, and minimizing downtime. Understanding your lab workflow is essential to identifying bottlenecks. By mapping every step from the initial request to final dispatch, you can pinpoint exactly where delays occur, such as a wait for spectrophotometer analysis. Strategy 1 is task prioritization. Categorize requests into high, medium, and low priority, and assign your most experienced staff to handle urgent or complex shades to keep production moving smoothly. Strategy 2 focuses on process standardization. Developing standard operating procedures for critical tasks and using checklists are vital steps to reduce rework and ensure consistent, high-quality results. Strategy 3 involves leveraging automation and technology. Tools like auto dispensers, integrated spectrophotometers, and digital tracking systems can significantly reduce errors and cut down on approval times. Strategies 4 and 5 center on lean management and training. Implementing 5S, encouraging Kaizen improvements and cross-training staff on multiple machines and shade analysis helps maximize flexibility and eliminate non-value-added activities. Strategy 6 is real-time tracking. By utilizing dashboards to monitor sample progress and setting alerts for any tasks that exceed 48 hours, you can proactively manage and resolve potential delays. When performing a bottleneck analysis, focus on identifying the weakest links. Whether it is limited equipment capacity, inaccurate recipe predictions, or poor communication, addressing the root cause is key to optimizing throughput. A well-structured daily production sheet is a fundamental tool for continuous monitoring, helping supervisors keep track of current projects, status updates, and overall team performance. This case study illustrates the impact of these strategies. By implementing automation, cross-training, and real-time tracking, a lab successfully increased productivity by 30% and significantly reduced approval turnaround times. Effective capacity planning uses a clear formula to determine how many machines and resources are required. By calculating based on samples per day and processing time, you can optimize your lab's hardware needs. Continuous improvement relies on the PDCA cycle: plan, do, check, and act. Establish a regular cadence of daily, weekly, and monthly reviews to stay aligned with performance targets and industry benchmarks. To wrap up, remember to monitor key metrics, apply lean techniques, cross-train your staff, and use data-driven decisions to plan workloads. Thank you. Welcome, everyone. In this session, we will focus on Chapter 12, Handling Bulk-to-Lab Coordination. This video explores the vital bridge between initial lab dip development and full-scale bulk dyeing execution, ensuring that perfect recipes translate into consistent, reproducible results on the production floor. Bulk-to-lab coordination acts as the essential link between the lab and production. Success relies on seamless communication, precise documentation, and technical alignment, ensuring that the lab's approved color recipes are replicated perfectly in the bulk dyeing process. Why does this alignment matter? It ensures, quote, right first-time production, reduces costly delays in rework, minimizes chemical waste, and builds buyer confidence. Without accounting for machine-specific differences, you risk shade variations that force expensive redyeing. Several key roles drive this coordination. The lab manager oversees recipes, the production manager aligns machinery, and the technician handles trial adjustments. Meanwhile, the QA/QC team verifies standards, and the merchandiser ensures clear communication with buyers throughout the process. The workflow begins with Step 1, lab approval, where recipes are finalized and confirmed by the buyer. Step 2 is the formal handover, where the lab provides the production floor with exact specifications, including dye percentages, chemical usage, liquor ratios, and precise processing conditions. The process continues with Step 3, running a pilot bulk trial to test the recipe. Step 4 is the full execution, monitoring shade consistency throughout the dyeing process. Finally, Step 5 closes the loop by recording any deviations to update the lab database for future accuracy. Documentation and control are critical. Essential records include the bulk recipe sheet, the handover form, trial reports, and deviation logs. Maintaining these documents, like the sample handover form shown here, ensures every team member follows the approved parameters. Smooth coordination depends on clear communication. This includes daily update meetings between managers, the use of shared digital dashboards or messaging groups for real-time tracking, and well-defined escalation protocols to quickly resolve any shade mismatches detected during production. Common challenges like shade mismatches, handover delays, or poor reproducibility are addressed through systematic approaches. By conducting bulk trials, using centralized management systems, standardizing production inputs, and implementing pre-approval processes, teams can proactively manage and resolve these issues. Technology plays a major role in modern coordination. ERP integration centralizes all recipe data, while specialized color management software synchronizes libraries. Additionally, IoT sensors provide real-time monitoring of dye bath parameters, ensuring consistency across every production batch. To measure success, we track key performance indicators, or KPIs. These include maintaining a lab-to-bulk RFT of 90% or higher, keeping approval turnarounds under 24 hours, and limiting communication delays. Tracking these metrics ensures our processes remain efficient and accurate. Continuous improvement is vital. We achieve this through weekly post-production reviews of mismatched shades, consistent database updates, regular staff training sessions, and benchmarking our facility's performance against industry standards to identify opportunities for growth. In one case study, a facility struggling with frequent mismatches implemented a digital recipe system, mandatory bulk trials, and weekly review meetings. Within 3 months, they achieved a 94% RFT rate, significantly reduced re-dyeing costs, and improved buyer satisfaction. Follow this quick checklist to maintain control. Before starting, confirm all approvals and machine calibrations. During production, monitor shade development and log all variables. After completion, compare the results against the standard and share your feedback with the lab team. In summary, effective coordination is critical for quality, cost efficiency, and customer satisfaction. By leveraging documentation, communication protocols, and technology, and by fostering a culture of continuous improvement, you build a more agile and reliable production environment. Thank you for watching. Let's now move on to the next chapter 13, documentation, record keeping, and compliance. Welcome to this video on documentation, record keeping, and compliance. We will look at a practical guide to establishing a robust system for daily textile color lab operations. Proper documentation is the backbone of a well-managed textile color lab. It ensures consistent dyeing results, provides traceability for audits, speeds up troubleshooting, and helps maintain compliance with key international standards and buyer protocols. Documentation is vital. It supports right first-time dyeing, data-driven decisions, and buyer audits. It also protects your organization during disputes and helps drive process improvement. For example, historical records help identify the cause of bulk shade failures. There are 6 core areas of documentation in the lab: lab dips, dye recipes, equipment calibration, quality control, compliance and safety, and buyer approvals. Each has specific retention periods, ranging from 2 to 5 years. Standard operating procedures, or SOPs, provide the step-by-step instructions for all lab processes. Work instructions complement these by providing task-level details, such as how to properly clean an auto-dispensing system. To maintain order, we also utilize checklists, logs, and reports. Checklists ensure no steps are missed, while logs and records capture daily operational data. Reports, such as monthly RFT reports, provide a high-level view of lab performance. To create an effective system, implement centralized filing with version control. Use a standard naming convention to keep files organized. Ensure accessibility for relevant staff while maintaining strict security and backup protocols for your data. Compliance with ISO 9001-2015 and ISO IEC 17025-2017 is essential. These standards mandate documented information for all quality-related activities, including traceable calibration logs for equipment, method validation records, and evidence of staff training and competency. In addition to international standards, brands often have their own specific documentation requirements. Some may require digital shade cards via online portals, while others may ask for daily calibration evidence for your spectrophotometers. Using templates helps maintain consistency. Common examples include the lab dip record sheet, the daily lab control sheet, and the calibration log. These templates capture the essential data points needed for day-to-day operations. Leverage digital tools to streamline your record keeping. ERP systems, laboratory management systems, and color management software can significantly improve efficiency. Additionally, cloud solutions offer secure storage. Remember, automation reduces manual errors and improves overall traceability. Follow these best practices. Always sign and date manual entries, update recipes immediately after changes, and conduct regular staff training. Ensure sensitive documents are kept secure and perform internal audits quarterly to maintain high standards. Before an audit, use a readiness checklist. Confirm your lab dip records are organized, calibration logs are updated, and SOPs are current. Also, verify that all non-conformance records are resolved and buyer approvals are easily accessible. Focus on continuous improvement by regularly reviewing your templates and logs. Hold feedback sessions with technicians to improve usability and benchmark your documentation practices against industry leaders to stay ahead. In summary, documentation is key to consistency, traceability, and compliance. Maintain both digital and manual systems for redundancy. Invest in regular training, and adopt modern technology to streamline your data management. Thank you for watching. Let's now move on to the next chapter 14, preparing for buyer visits and lab audits. Welcome everyone. In this session, we will focus on Chapter 14, preparing for buyer visits and lab audits. This video outlines the essential steps for maintaining a high-performance textile color lab that is always ready for evaluation. Buyer visits and lab audits are critical checkpoints in a textile lab. They assess your technical capabilities, consistency, and compliance. Proper preparation builds buyer confidence and strengthens long-term business relationships. Audits range from technical and process reviews to compliance, follow-up, and buyer support visits. Each type has a distinct focus, ranging from infrastructure calibration to collaborative R&D and closing out previous nonconformities. Key audit objectives include assessing lab infrastructure, verifying documentation accuracy, evaluating staff competency, and monitoring safety protocols, alongside reviewing right first-time performance. Preparation is key. Ensure your documentation, such as SOPs, calibration logs, and tracking sheets, is up to date. Verify that all equipment, including spectrophotometers and dispensers, is properly calibrated and serviced. Maintain a safe and organized lab environment. Keep MSDS sheets visible. Ensure staff are trained for audits, and keep records of data and CAPA logs easily accessible to demonstrate your compliance efforts. Organization is vital for documentation and calibration. Use indexed binders or digital systems to manage records. Maintain a visible calibration status board to quickly confirm that all equipment is within its required schedule. Ensure SOP compliance through regular internal mock audits. Staff should be able to explain processes confidently. Prioritize daily inspections of safety features like eye wash stations and first aid kits. Use data to your advantage. Prepare trend charts to visually demonstrate continuous improvement in your right first-time performance, highlighting successful optimization efforts. When conducting the audit, start with an opening meeting to introduce your team and agenda. During the facility walkthrough, guide auditors through key areas while ensuring everything is clean, organized, and running smoothly. This scene is intentionally blank. After the audit, analyze the report, prepare corrective action plans with assigned responsibilities, and hold internal review meetings to address any findings before the next visit. Utilize audit readiness templates. These include preparation checklists, CAPA trackers, and summary reports to keep your lab organized and ensure nothing is overlooked during preparations. Best practices include maintaining constant audit readiness, transparent communication, and fostering a culture of ownership among your staff so that compliance becomes an everyday habit. In summary, avoid common pitfalls like outdated logs or poor housekeeping by implementing regular systems. By training your staff and treating every audit as an opportunity to improve, you will maintain a superior lab standard. Thank you for watching. Let's now move on to the next chapter 15, Continuous Improvement and Lab Innovation. Welcome everyone. In this session, we will focus on Chapter 16, the Lab Manager's Golden Rules and Cheat Sheets. Running an efficient textile color lab requires discipline, consistency, and practical problem-solving skills. This video outlines the essential rules and tools for success. In this chapter, we cover proven rules, quick reference guides, and ready-to-use cheat sheets to ensure your lab operations run smoothly and maintain high performance. Our first 3 golden rules focus on essentials. Prioritize accuracy to achieve right first-time results. Master your time management, and foster powerful communication across your team and partners. Next, remember that data is your best friend. Maintain equipment health for reliability, and always strike the right balance between cost efficiency and shade accuracy. Building high performance is about people and processes. Stay audit ready, commit to continuous improvement, and always approach challenges as a proactive problem solver. Efficiency starts with a daily routine. Use this checklist to ensure your team is calibrating equipment, reviewing approvals, tracking results, and keeping the workspace clean. When color matching, use this cheat sheet for quick adjustments. Whether you need to correct for shade lightness, depth, or specific color tones, these guidelines provide immediate solutions. For accurate spectrophotometer readings, follow these steps. Calibrate daily, keep sample tiles clean, use standardized D65 lighting, and always save your data with proper batch information. Effective communication is vital. Use this template for daily lab dip approval updates to keep buyers and merchandisers clearly informed of the status of their style requests. Use the weekly review template to monitor your KPIs. Comparing your current performance against targets allows you to identify areas for immediate investigation or improvement. For your monthly golden review, track these critical points: staff training, inventory levels, maintenance compliance, and overall trends in performance to keep your lab on track. Save time with these ready-to-use templates, including log sheets, coordination forms, and audit checklists, helping you keep your records organized and traceable. In an emergency, stay calm. Whether dealing with equipment failure, dye shortages, or shade rejections, use these predefined quick fixes to resolve issues and maintain workflow. The key takeaways are consistency, using tools to minimize errors, maintaining organized archives for audits, and conducting regular reviews to keep your lab agile. Thank you for watching this video. Remember, maintaining discipline, consistency, and strong problem-solving skills is the foundation of a successful textile color lab.